All right, hello everyone. We are taking a look at 10.5 today, looking at other types of angle relationships inside of circles. So in 10.2 and 10.4, we did types of angle relationships, and now we're going to learn about three more. And each one of these relationships depends on where our lines or our segments intersect around a circle. So this is going to be broken up into three different videos, one on each different type of relationship, just to break it down a little bit easier. So this first video, we're going to be looking at if we have lines or segments that intersect on our circle. So for example, if we have a line right here and we have a line right here, we have that these two intersect on the circle at this point. So that's going to be our first type of relationship we're going to be looking at. So this relationship mostly looks like what we call a tangent chord relationship is what this is going to be mainly looking like. So basically it's where we have that a tangent and a chord intersect on a circle. So here we have this tangent line down here, and we have chord AB right here. And we have that those two intersect at point A. So here we have a tangent and we have a chord. All right, so these two have basically a special type of relationship when we're talking about being on the circle. So when we're talking about an angle that those two form, so for example, 1 and 2 are both formed by that intersection, we have that angle is going to be equal to 1/2 of the arc measure. So 1/2 of our arc. So what that looks like in each one of these individual cases is that, say for example, we wanted to find angle 1 right here. So we would say that the measure of angle 1 is equal to 1/2 of its corresponding arc. So this is very similar to our intercepted arc or our intercepted angle when we are looking at basically our arc and our inscribed angle in comparison. So it's basically the same thing, just with one of the sides being part of a tangent instead of being another chord in the circle. So we have that the measurement of angle 1 is going to be half of that arc that I have bolded here. So it's going to be half of arc AB. And we can also do that with our other side, so it doesn't just apply to minor arcs, it also applies to major arcs. So let's say we wanted to find the measurement of angle 2. So the measurement of angle 2 is going to be half of this measurement of this arc. So we have it's going to be half of our arc AC. And what's also neat about our arrangement here with our chord and our tangent is that if we take the measure of angle 1 and add it to the measure of angle 2, so if we add these two angles together, they're going to be supplementary, so they're going to add to 180 degrees. All right, so let's take a look at a few examples. I have 3 different examples lined out for us. So our first example, we want to find the measure of each missing arc and each missing angle on this diagram. And so we're saying that line M is tangent to the circle. So we're given one arc already. We're given this large arc right here. So there are a few different ways that we can go about solving on this diagram. We can, for example, since we know this large arc here, we are going to know our angle down here. So I'm going to add, let's say, T here. so that we can do our measurement of our angle TVU, and we know exactly which angle we're talking about. We have, since that's going to be half of our arc measure, so it's going to be half of 228, which if we did the math on that, we have that that would be 114 degrees. Here. All right, so we can find either our next angle on the other side here, or we can find this arc of UV if we want. So let's find UV first, actually. Because if we think about a circle is 360 degrees. So all the way around here is going to be 360. All right. So if we take that into account, we have that, well, the arc that we already have is 228 degrees. So again, this arc right here, 228. We can take 360 for all the way around the circle and subtract off that 228. So if we do that, we're going to get 132 degrees. So that's going to be the measure of our arc UV. Oh, that's an arc, it's not a segment. It's going to be 132 degrees. So the one on this side here. Again, because it takes up the rest of that 360 degrees. All right, and then we can do the same thing here for our angle down here, this one. And so let's put W right here for a point. So now if we're talking about the measurement of angle UVW, so the one on the other side of that 114, it's going to be half of that 132 or 132 degrees. And if we have the half of that, that's going to be 66 degrees for our measurement of angle UVW. All right, so you can also, if you want to find the measurement of this angle, another way that you can do that is, well, like I said before, the angles here add up to 180 degrees, so you could do 180 minus 114, and that would also get you 66 degrees. So you can do it either way. All right, so the next one, if you want to try it on your own, pause the video and then come back to get answers from, well, the video. But try to pause it first because I do want you to try it first. All right, so we're given this angle here on our circle. And so we have that's 118 degrees. So if we wanted to find our larger arc, we basically have to do our other formula backwards. So instead of taking half of our arc to find our small angle, in order to undo that, we can multiply it by 2. Because for example, our 118 is equal to 1/2 of our WX arc here. So in order to get the 2 on the other side, we can multiply by 2 and multiply by 2. So those cancel out, and so we have basically our WX is equal to 2 times 118, which if we multiply that out, that's going to be 236 degrees. Oh, whoops. All right. So we have that our angle for our arc here is 236 degrees. All right, so next, if we want to find our other two angles or our angle and our arc, we can find this angle here. We can do that by taking we know that together these are 180 degrees. So if we subtract off the 118, we're going to get 62 for that angle. So we have 62 degrees. All right, next if we want to find our arc on the other side, so this arc XW. So maybe this one. So we got to be careful when we're talking about our arcs for X and W, just because we don't want to confuse them together. So we have one arc is 236. The other arc is going to be 2 times 62. So if we do 2 times 62, that's going to give us 124 degrees. So 124 degrees up here. All right, and that also works out if we take our 236 plus 124, that is going to be 360 for the total amount of our circle on the outside for our degrees. All right, so let's take a look at our last problem. So here we want to solve for x. Again, if you want to try this one on your own, make sure that you pause the video. But here we're just finding one variable. All right, so we are given one arc. We're given the measure of this arc, that's 122 degrees. And our goal is to find x, which is this angle right here. All right, so there are a few different ways that we can go about this problem. So basically, there are two different ways that we can do it. One way is that we can take half of 122. So if we take half of 122, that's going to give us 61 degrees, and that's going to be this angle right here. All right, and we know that these two angles together have to be 180, so we can take 180 minus 61, and if we do that, that's going to be 119. So that means our x is going to be equal to 119 degrees here. All right. Another way that that can be done is, well, we can go the whole circle route. So again, the whole circle is 360 degrees. If this part is 120, we can subtract that off for the rest of, or 122, excuse me. We can subtract that off for our the rest of the arc on our circle, so the other arc that is not mentioned. So if we subtract that, that's going to give us 238 for this big arc right here. And then, well, half of 238 is 119. So you can do it either way, both will get you the exact same answer. All right, so that wraps up our angles that are on our circle. Basically our tangent chord relationship. So make sure to watch the other two videos to see the other two relationships that are in 10.5.